Chapter 8. Nature of Matter, Elements, Compounds, and Mixtures. Mixtures. Mixtures are formed when two or more substances get mixed physically without any chemical change. Each substance in a mixture keeps its own properties and can often be separated by simple methods. In some mixtures, components are easy to see with the naked eye. Example: in a fruit salad made of apples, bananas, and grapes, each fruit is clearly visible. These mixtures are called non-uniform mixtures as their components are not spread evenly. Other mixtures, like sugar dissolved in water or soft drinks, look the same throughout, and you cannot see the separate components even with the help of a microscope. These are called uniform mixtures because the components are mixed so evenly distributed that they appear as one and cannot be distinguished. Alloys are special kinds of mixtures made by mixing two or more metals or metals with non-metals. For example, brass is made by mixing copper and zinc, bronze is a mixture of copper and tin, and stainless steel is made by mixing iron with nickel, chromium, and a small amount of carbon. Air, uniform mixture. Air is a mixture of gases that surrounds the Earth, consisting mainly of nitrogen, 78%, oxygen, 21%, and small amounts of argon, carbon dioxide, water vapor, and traces of other gases. Nitrogen. It makes up the largest component of air and is chemically inert. It helps in regulating life processes such as respiration. Oxygen. It is essential for breathing and combustion. Carbon dioxide. It is necessary for photosynthesis in plants. Water vapor. It adds humidity to the air. Argon and other gases, present in very small amount, are chemically inert. Since the proportions of all these gases remain nearly the same in every part of the atmosphere and the components are evenly spread, air behaves like a uniform mixture. The components of air retain their individual properties. Air also contains unwanted substances called pollutants, which include dust, smoke, soot, and harmful gases such as sulfur dioxide and nitrogen dioxide. Pollutants are not an essential part of air but mix with it, making the air impure. Air Quality Index, AQI, is used to describe how clean or polluted the air in a given area is. A low AQI means clean air, while a high AQI indicates polluted air. Types of mixtures. Mixtures occur in many forms depending on whether their components are gases, liquids, or solids. The way these substances combine decides whether the mixture appears uniform or non-uniform. Air is a gas and gas mixture type. It is a uniform mixture. Aerated water or soda water is a gas and liquid mixture type. It is a uniform mixture. Oxygen dissolved in water is also a gas and liquid mixture type. It is a uniform mixture. Carbon particles in air form a solid and gas mixture type. It is a non-uniform mixture. Acetic acid in water, also known as vinegar, is a liquid and liquid mixture type. It is a uniform mixture. Oil and water form a liquid and liquid mixture type. It is a non-uniform mixture. Sand and water form a solid and liquid mixture type. It is a non-uniform mixture. Seawater is a solid and liquid mixture type. It is a uniform mixture. Baking powder, which contains baking soda and tartaric acid, is a solid and solid mixture type. It is a non-uniform mixture. Alloys are solid and solid mixture type. They are uniform mixtures. Pure substances. In everyday life, the word pure is often used to describe products that are unadulterated. For example, when we see labels such as pure ghee or pure milk, it usually means that these products are not mixed with cheaper or harmful materials. Adulteration is the process of adding unwanted or low-quality substances to a product to increase profit. It lowers the quality of the item and may even make it unsafe. A pure substance is one that is made up of only one kind of particles. It does not contain any other substance mixed with it. Even if a substance looks clean to us, it can be impure scientifically if it contains more than one type of substances. Characteristics of pure substances. They consist of only one type of particles. Their composition is uniform throughout. They cannot be separated into other kinds of matter using physical processes such as filtration, evaporation, or distillation. They have fixed properties, such as a definite melting point, boiling point, and density. From a scientific point of view, many items that people may consider pure in daily life are not pure substances. Milk is actually a mixture, as it contains water, fats, proteins, vitamins, and minerals. Packed fruit juice is a mixture of water, sugars, fruits flavors, and nutrients. Baking soda is a pure substance as it is made of only one kind of particles. Sugar, sucrose, is a pure substance as it is made of only one kind of particles. Soil is a mixture since it contains sand, clay, minerals, water, organic matter, and air. Types of pure substances. Water exists in 3 states: ice, liquid water, and water vapor. On cooling water, we get ice, and on heating it, we get vapor. We can get back water either by heating ice or by cooling water vapor. However, in all these processes, the composition of water does not change. Thus, water is a pure substance. When electricity is passed through water, it splits into 2 different gases, hydrogen and oxygen. The process is known as electrolysis. This tells us that water is made up of 2 different constituents, hydrogen and oxygen. Pure substances can be grouped into 2 types: elements and compounds. Elements. Hydrogen and oxygen, formed by the decomposition of water, are pure substances known as elements. An element is a substance that cannot be broken down further into simpler substances by any physical or chemical method. Examples of elements include gold, silver, sulfur, and carbon, etc. Each element is made up of identical particles called atoms. The atoms of one element are different from the atoms of another element. Atoms of most of the elements are not stable when existing alone. To become stable, 2 or more atoms of the same kind combine together to form a molecule. Classification of elements. Metals. Elements such as gold, silver, magnesium, iron, and aluminium are metals. Non-metals. Elements like carbon, sulfur, hydrogen, and oxygen are non-metals. Metalloids. Some elements, such as silicon and boron, have properties of both metals and non-metals. These are called metalloids. Elements and their states. At present, 118 elements are known. They exist in different physical states under normal conditions. Most of the elements exist in the solid state. 11 elements exist in the gaseous state at room temperature. Example: oxygen, nitrogen, helium. All of these are non-metals. 2 elements exist in the liquid state at room temperature. Example: mercury, a metal, and bromine, a non-metal. Some solid elements, like gallium and cesium, turn into liquid at slightly above room temperature, around 30 degrees Celsius or 303 K. Importance of elements. More than 45 different elements, such as aluminium, copper, silicon, cobalt, lithium, gold, and silver, are used in the manufacture of mobile phones, including their components like batteries, screens, and circuits. Water molecule is made up of 2 atoms of hydrogen and 1 atom of oxygen. These 2 elements are so tightly bonded to one another that they cannot be separated by any physical method such as filtration, evaporation, or distillation. Thus, water is considered as a compound. Compounds are pure substances formed when 2 or more elements combine chemically in a fixed ratio. The elements lose their individual properties, and the resulting compound shows entirely new properties. Hydrogen is a fuel. Oxygen is a supporter of combustion. But when they chemically combine, they form water, which is used to extinguish fire. Sodium is a soft and highly reactive metal, while chlorine is a poisonous gas. When combined in a 1:1 ratio, they form sodium chloride, common salt. Compounds can only be separated into their constituent elements by chemical changes. Water molecules are made up of hydrogen and oxygen combined chemically in a fixed ratio of 2:1, 2 atoms of hydrogen for 1 atom of oxygen. Thus, compounds are pure substances formed by the chemical combination of elements in fixed ratio. Uses of elements, compounds, and mixtures. Uses of elements. Elements such as oxygen are vital for respiration in humans and animals. Nitrogen, present in the air, is used in making fertilizers. Iron and aluminium are used in constructing bridges, vehicles, and buildings. Gold and silver are used in jewelry, coins, and electrical connections. Uses of compounds. Water is essential for all living organisms. Common salt is necessary in our diet and is also used in food preservation. Medicines and vaccines, most of which are chemical compounds, are used for treating and preventing diseases. Fertilizers contain compounds such as ammonium nitrate and urea, which improve soil fertility and increase crop yield. Uses of mixtures. Air is a mixture of gases like oxygen, nitrogen, and carbon dioxide, all required to sustain life on Earth. Alloys such as stainless steel, brass, and bronze are mixtures of metals that are stronger, more durable, and corrosion resistant. Building materials like wood, cement, concrete, and steel are mixtures that provide strength and versatility in construction. Petrol and diesel are mixtures of hydrocarbons used as fuels in vehicles. Minerals. Minerals have a definite composition and are the basic building blocks of rocks. Some minerals are native minerals made of only one pure element. Examples include gold, silver, and copper, metals, as well as sulfur and carbon, non-metals. Most minerals, however, are compounds formed by combining two or more elements. Examples are quartz, calcite, mica, pyroxene, olivine, and talc. Minerals in daily life. Cement is made from calcite, quartz, alumina, and iron oxide. Talcum powder is made from talc. Thus, elements and compounds are the building blocks of matter.